Hello everyone, good evening and welcome to this session of the Borderless Cairo Bootcamp. Um, in the last session, we talked about Cairo and how it can be used to write provable code. So in this session, we are going to be writing a basic ENS contract, and also going to be deploying it to a local testnet. Um, in the previous mail, we already sent a um, like, already sent the link to the tools you'll be needing to set up your development environment, and we really hope that you have been able to set up your development environment. And if you have not been able to, please do well to reach out to us on the Telegram and Discord groups, and we'll be able to help and put you through on how to go about it. So, one of the tools we are going to be using is SN Forge, which is the Foundry Stacknet Foundry, which can be used to write and test your smart contract. So, um, you are meant to have had it installed by now. So to check, you can do SN Forge version. Yeah. So we can see that it has been installed. So we can then go ahead to create a project. We're going to call the project Bootcamp SN Forge init Bootcamp. Cairo, let's call it Cairo Bootcamp. Cairo Bootcamp. So with this, we can then cd into it, Cairo Bootcamp, and open it up. So when we open it up, then when we open the Cairo Bootcamp up, we can see that we have some templates projects basically that we can work on. You can see here we have a template of a project that can increase and get the balance of a person, and we can also see that we have a test that is pre-written for us. So one thing we can do is to go ahead and run the SN Forge test. When we run this, it's going to compile the project and run the test for us. Okay, so with this, we can see that the tests are passing. So now what do we want to do? We want to create a minimalistic version of an ENS contract. So we need to go ahead to modify this. So let's just remove everything and basically start from the scratch. Okay, so basically everything in Cairo is a model. So what we can do, first of all, we need to check the scarp.toml, and we need to make sure that we have Stacknet here, right? In our dependencies, we need to make sure that we have Stacknet here and the version. So this SN Forge that is here in our dependencies is just to help give us additional functionalities that comes with SN Forge that can enable us to test our smart contract and give us some extra features. So another thing is here under the target.stacknet contract, we can also include the Sierra equal to true, so that when we compile our contract, we can have access to. We can also get the Sierra file. So we save that, and then this you can also see the scarp.log here and the gitignore basically, and we can also see the test. The target here is gotten when we compile the contract. So we can see if we take this off, if we delete it, and then we come and compile, can use scarp build. You can see it generates it for us. Okay, and then this lib.cairo is where we'll be writing our program. So let's jump right into it. So first of all, we're going to be defining our mod, which is going to be the contract. Let's call it Borderless. Okay, and to show that it is a contract, we need to put the we need to derive the stacknet contract here. The stacknet. So this stacknet contract is basically what will give us some functionalities inside our this thing, inside our contract. So with that, we can then go ahead. We need to also define our storage, the storage struct basically, and to do that, the struct storage. So this struct, whenever you have a stacknet contract, you have to define this struct, even if you're not storing anything in storage, but you need to have this struct defined. So when you define this struct, you need to also append, like you need to also derive storage here, and then with this we can then go ahead to create a like we can go ahead to define our functions in the contract. So how we can do this is by using an implementation block. I'm going to implement the borderless traits of I'm going to implement basically borderless of the borderless trait. Okay, and with this we need to indicate actually by using the external v0 to show that these are external functions. So any function that is inside this implementation block is going to be an external function which can be accessible from the contract ABI. So every ENS contract basically has two. We can have as many external functions, but the two that we are going to be defining here are the set name and the get name. So we have the function get name and the function set name. Okay. Okay, so these are the two functions we are going to be having, and these functions, they are going to be needing access to the contract storage, right? Because they are going to need to read and write from the contract storage. So one way we can go about it, because we are going to actually need to define this, the interface basically, but one way we can go about it is by using the generate trait. And using the generate trait. We can also use that. Okay, so basically if we do it that way, so generate it for us. So I just get rid of this. Okay, by using the generate trait. So when we use this generate trait, Cairo automatically generates a trait for us. We don't need to define our trait by ourselves, but then like this is one approach to go about it. But then if we want to define our trait by ourselves, we can come here and say traits, and then just remove this, let's type it on our own. So let's say we call it the borderless trait. Okay, and then it's going to take in a generic parameter basically, which is going to be the contract state. Okay, and basically this borderless trait, we are going to be needing it in this function here basically. But first of all, let's define the functions that this borderless trait to have. We need the get and the set, right? So we have the function, we have the get name. Okay, and this get name, basically we are reading any function actually takes self, and the type of self is going to be the contract state. Okay, but one thing we know is that the get name does not modify storage, so we need to pass in a snapshot of the contract state, and then we also need the address of the person we want to get the person's name. So let's call it address, and it's meant to be a contract address. So this contract address type can be gotten from the StackNet. So use the use StackNet contract address basically. So with this we can use this contract address here. Okay, and it's meant to return a felt failed 252. Okay, so that is one. Another thing also, since this is an interface, basically we need to derive the stacknet interface actually. Yeah, so we need to derive this. So the next function we need to have is the set. So we have function set name, and as usual we are going to take self, and since we know set name is going to modify storage, so what we need to take is not just self but a reference to self, so that we can modify the storage with, and it's still going to be the contract state. And so the set name, basically what we want is that the person calling the function, well, is the person that is basically setting the name. Okay, so anybody calling this function will need to pass in the name that the person wants to set to the person's address, and that name is going to be of a failed 252 type, and this function does not necessarily need to return anything. So that's it for this interface. And then the next thing that we can do is to import it here. So we're going to use super and then the borderless street, and then we'll need to use the borderless street here, and the borderless street now is meant to take the contract storage. So that contract storage, the contract state, so the contract state is part of the things we get access to when we define a stacknet contract. So we have the contract state here. Okay, so with this, basically we can see that our contract is now taking shape. So since we are actually implementing the we are trying to implement this interface basically, so we are going to need these two functions. We are going to need to implement them. So let's just get rid of this for now. Okay, so these are the two functions we need to implement. Okay, and now here we are no more meant to be taking in the T contract state because we are using the contract state here, so we need to take off this T, and that means we're taking a snapshot of the contract state, and then here we're taking a reference to the contract state. So next we are going to need to remove this, and then our function will go into this place. Same thing here, we need to remove this, and then our function will go into this place. So okay, let's define our storage basically. So in our storage, we want to be able to get basically this contract. We need an owner for the contract. Okay, so let's say an owner, and the owner is expected to be a contract address. It's expected to be a contract address. Okay, so we also need to, because of this mod here, everything inside here is basically like separated from whatsoever is inside here, because this is a new model and this file also is a model. So what we can do is we can also import the stacknet contract address by doing use stacknet contract. Okay, so with that we now have access to the contract address here, which we can use here. So this was the contract address of the owner, basically the person that deployed the contract. Okay, sorry. So this is meant to be a comma. And next, we need a way to map an address to a name. So let's define address so name, and it's going to be a legacy map. Basically, a legacy map is just like a map in Solidity, and this legacy map is going to be mapping a contract address, to a felt 252, which is the person's name. Okay, another thing we want is we don't want two people to be able to use the same name, basically. So we need a way to be able to check if a name has been used. So one way we can go about this is by using another mapping of let's call it is available. Okay, is available, and it's going to be a legacy map of a name, basically, to a bool. That is so that we can know if the name has been used. So basically with this, I think we're also going to need like a function to be able to get the owner of the contract. Let's say function get owner, and basically get owner, since we know that it's not modifying the contract storage, we can take self and a snapshot of the contract state. Okay, and it's just going to return the owner of the contract, which is basically contract address, which is basically a contract address. Okay, so with that, we also need to add this to our implementations, because we need to implement everything that we have defined in our interface. We need to implement it. Okay, so we need to implement it, and then can remember we need to take this off. Okay, so basically these are the three functions we are going to be having in our contract. But since we are using this interface, there's no need actually for this generate trait again. So basically, if we did not define our interface here, this generate trait would have helped us to generate this interface here. But since we have defined our interface, so there's no need for this, so we can take it out. Okay, another thing also is we need to define basically a constructor, because we want to set the owner of the contract at deployment, basically. So we need a constructor. To define a constructor, we need to define a function named constructor and we also need to derive the constructor. So I need to define the constructor. So okay, so basically the constructor is meant to take in the address of the owner so that we can then set it. So it's going to take in an address of type contract address, and what we want to do is to set self dot owner. We want to set the owner here, owner, and we want to write, okay, the owner, and we want to write the address. Okay, so with this, the constructor is good and ready. So next thing is let's write out our functions basically. So for the get owner function, what we want to do is to get the owner, so self dot owner dot read. So one thing we could do is to store this as a variable and then return that variable, but this way will still work in as much as we don't put a semicolon here, because there's something we call the implicit and the explicit return. So in this case we want to use the implicit return. Okay, so in that case we don't need to go ahead to do like return this self dot owner dot read. Yeah, we don't need to go ahead to do this, okay, since we can just do it implicitly, because this is like explicit return, because we're basically telling it like return this. So this will still work. Basically we're reading the owner, and then since we don't have the semicolon here, it returns it. So that is that for the get owner function. Next, we want to be able to get the name of the address passed. Okay, so how we can do that is by self dot address to name dot read. Want to read the address name, and then we're going to have to pass in the address here, and then when we pass in the address, it basically returns it because we're using the implicit return here. Okay, and then the next function we need to write is the set name function. So the set name function, first of all, we want to be able to get the address of the person who called this contract. Okay, and to do that, we can do that with the help of the get caller address function, basically, that is exposed to us from Stacknet. So we'll need to import it. Get caller address. Okay, so Let's create a variable. Let's color address go to get. Okay, and so after we get the color address, okay, the next thing we want to check the name. Okay, or first things first, what we want to check is if the name is already in use, right? If somebody have used the name already. So to check that, we need to set, okay, self dot is available, read, and we need to pass in the name. Okay, so we want to be sure that the name is available, so we want to assert that it's true, that is available. Okay, so if it's not available, we want to tell the person who called the function name already used. Okay, so but then if the name is available, then we can go ahead to get the caller's address, and then we can go ahead to save the name to the person who called the caller's address by self dot address to name, and now want to write. Okay, then since we want to write it, we are going to need to pass in both the key and the value. So the key in this case will be the caller address, and the value will be the name. Okay, so once we have done this, we now want to set the is available to false, so that the next person that comes will not be, that tries to use that name, will not be able to use it. Okay, so what you can do is now self dot is available, right? Okay, so we're going to take the name and false. Okay, so with this, basically I think our contract is ready, so we can save, and then let's just comment everything out in our test for now, because it will basically break since most of the functions that we've been called here are no more available. So let's comment it out. So after commenting it out, we are then going to save it and then try to compile our contract to make sure that our contract is compiling before we proceed with the test. Okay, so scarp build to compile our contract, and as you can see, our contract is compiling basically. Okay, let's just delete this again and then compile. Okay, so we can see our contract is compiling, and we have this available to us. Okay, so next thing is to write our tests for the contract. So to write our tests for the contract, we want to be able to test that when we set a name, that it actually sets, and when we get it, we'll be able to get the name that we set. Okay, so that is basically what we want. And so let's write our test. So basically this deploy function is more like a utility function. Okay, first of all, let's just take this off since they are no more there, and we'll import the one that we'll import the one for our borderless we'll import the one for our borderless program that we wrote. Basically that is the I borderless trait, right? Which is this, like the I borderless trait here. Okay, and we also want to import the I borderless trait dispatcher. Also want to import the I borderless trait dispatcher. Okay, so with this to basically this function here, okay, the contract address is just to enable us get access to like the contract address type and the declare and the okay, so the the declare and contract trait here is to enable us get access to this function, to enable us declare our contract basically, because we need to declare our contract before you can deploy. So when you're declaring your contract, it's basically making the contract available to the network, like telling the network, oh, a contract have been written, and we basically get the class hash after declaring the contract. So that class hash is more like an identifier to the contract that you wrote. So this declare here and the class contract traits are like utilities that we're going to be using, and then the I borderless trait here and the I borderless dispatcher are what will enable us to basically those are what will enable us to interact with our contract. So next we have the deploy contract here. So this function, it takes in a name and it returns a contract address. So it basically declares the contract and then it deploys it. Okay, but one thing we should know is that in our case, since we are passing in a parameter to the function, we are going to need to also take in that parameter here basically, which is a contract address, and then basically with it we need to create a like let's say let mute call so like our parameters, we usually pass them as an array. So with that we can then append the address to it. Okay, Since it's a contract address, we need to convert it into a field type because the deploy function basically takes an array of fields. So next is we'll pass in a snapshot of that, of the core data. We need to pass in a snapshot of the core data to the deploy function, and then it will return a result type which we need to unwrap. So after this, next thing, okay, let's just take out this. Okay, so next thing we want to test basically is the set name. Okay, test set name, and we want to deploy our contract. But here our contract name is actually Borderless. Okay, Borderless, because you can remember here that our contract name is Borderless. Okay, so with that, we have to make sure that that is what we're passing here. Okay, to the deploy contract, and we also need to pass in the address of the owner. Okay, let's call it owner address. Now this owner address, we don't have it yet, so we need to declare it. Let's owner address be equal to contract. Let's just create a dummy address. Okay, contract okay, so let's just call it owner. Okay, right, and then the owner address, we then pass it here. But this contract address const is a function that we need to also import. So contract address const, we need to import it, okay, to enable us use it here. So another thing is, okay, since we've gotten it and we've deployed the contract here and we've gotten the contract name, so the next thing, we need to pass this contract name to our dispatcher. Actually this okay, let's just take off all this. Okay, so what we've done here now is that we've created the owner address and we've deployed the contract, so we have the contract address here. So now we need to get a way to interact with the contract, right? So let's call it the contract. Let's contract equal to, then we need this borderless straight dispatcher. Borderless straight dispatcher, and it takes in the contract address. Takes in the contract address. Okay. So with that, basically we can then interact with the contract. Okay, so um okay, since we've deployed, okay, let's make this a test deployment instead. Okay, so we want to make sure that the owner is actually the person that we set as the owner. So how we can basically do that is that we need to assert, okay, that the owner, which is the contract, gets owner, because this gets owner, we then need to unwrap it actually. Okay, is equal to the owner address we have here. Else, if it's not, then we can say wrong owner. Okay, so with this, basically probably our first test is ready. So what we can do is to save and then run our SM forge test. Okay, okay, so we're having an error here. So method get owner not found on type. Okay, okay, so let's treat dispatcher. Let's just figure it out. Okay, so this the trade dispatcher, going to be a trade dispatcher trait here. Yes, a trade dispatcher trait, which we are also meant to use here. Okay, so I think this unwrap get owner, correct? Get owner, right? Get owner, and I'm making a mistake with the function name, right? Get underscore owner. Okay, so with this, let's save and let's try it again. Let's forge tests. Okay. Okay. Borderless traits, dispatcher traits. Okay, I think this, we also need to import the borderless, yeah, trait dispatcher trait here. Yes, We also need it here, and the test, we need the borderless trait, trait dispatcher trait. Okay. I think those are basically what we need. The trait dispatcher and the trait dispatcher traits. Okay, those are basically what we need. And so we have the borderless traits, dispatcher traits. We also need the borderless traits dispatcher. Okay, this, let's try it one more time. Okay, not the type. Okay, that's it. Like, okay, the trait dispatcher has what we need. Yeah, the trait dispatcher. So the trait dispatcher trait is just a trait on the trait dispatcher type. So with that, we can see that our test is passing, and that the owner basically is the owner that we defined here. Okay, so that means our deployment works fine, and the next thing we want to do is to set a name, right? Let's write a test to set a name. Okay, so we need to test and test set name. Okay, and basically since we've tested the deployment, so we can just do what? Okay, let's just get what we need from here. Okay, so after getting the address, we want to set a name and then get it. But to set a name, we need to let's say we need an address that will actually call the set name function that we can later check. So let's just call it addr be equal to the contract address const. Let's call the person user, right? Okay, and then we need to prank the contract. So to prank the contract, we actually need to import from the standard. We need to import cheat code, and we need to import the start prank. We need to import cheat codes and the start prank. And also the cheat target. Also need to import the cheat targets. Also need to import the cheat target. Okay. So so with this, basically we then need to start a prank. So we need to start a prank. I don't know why my Cairo 1 extension is not working, but then we need to start a prank. Okay, and it needs the address of the contract that we need to prank. So call the cheat targets and 1, because we need to prank it. There are also other variants of the cheat target, but the one we're working with for this test is just the one, and it's the contract address we want to prank, and then we want to prank it with this address, the user address, ADDR. Okay, so once we started the prank, we can then call the set name and passing Borderless as the name. Okay, so after setting the name, we want to be sure that it was set, right? So we need to assert that the contract, and we try to get the name of this user, basically. Now it should be equal to Borderless, right? If not, then it's a wrong name that was set. Okay, so with this, let's save and run our test. Forge tests. Okay, name already used. Okay, so it's the set name. Borderless. Name already used, basically. Okay, name already used. This is the error we got. So okay, so we're basically saying like self dot it's available, and it's meant to be false initially because that is like the default. Okay, so okay, so with this we can see there was actually like a bug in our contract. Yes, there was actually a bug in our contract because here we are still setting it to false when it's actually false. So I'm meant to be setting it to true. Okay, and since I meant let's let's refactor our code a bit. Okay, it's available, it's used. Okay, so let's say it's used and want to, if it's used is true, then we want to um revert basically, but we don't want this, we don't want this used to be true, we want this used to be false. So if it's false, we are negating it here, and then here we set this to true. So with this, I think we're good. So let's save, let's rerun our test. So when we rerun our test, it is going to rebuild the contract and then run the test. So sm forge test. Okay, sorry, this is used, it's used, save. Okay, okay, with this we can see that our two tests are passing now. Okay, our two tests are passing now basically, and with this basically there is we can go ahead, let's go ahead and deploy. So to deploy the contracts, we can then okay, we need to have the katana running. So we already sent you guys a link in the mail on how to go about installing Katana and Stackly, because we are going to be needing Katana and Stackly for this deployment phase. So basically Katana is a local development environment, just like your hard hats or your casts for Anvil, for Foundry, and your Stackly is what enables you to interact with that local development environment. So you can do like Stackly version 2. Yeah, so the Stackly is installed, and also you can do Katana, you can run Katana, and when we run Katana we can see that it gives us some address. Okay, it gives us some address, and like that we can use actually to test our contract. Okay, so with this, let's go ahead to create accounts that we're going to be using for these tests. Okay, so if we check the Stackly documentation, okay, we'll need to like check the Starkly documentation. Starkly. Okay. So um okay, so we need to check the Starkly documentation, and then like basically the Starkly documentation has everything you need to set up your like Starkly account. In this like the Starkly book. Okay, so we'll go to accounts. So basically here you have like everything you need to set up your account, how to set up your account, how to fetch it, and like basically everything you need. So we're going to be creating a Starkly account, and then we are going to be deploying our contract to the local testnet. Okay. Let's go ahead. First of all, we need to like create a signer, and like this is basically what we need to create the signer, and then from that we can also create like fetch the account. So let's go ahead and continue. Let's go ahead and continue. So we can to deploy our contracts, basically we are going to be needing, let's create a .env file. .env, because Starkly needs some environment variable setup that we can then use to interact with the blockchain. So we need the Starknet RPC environment variable, which is basically this. But in a case where you want to deploy to mainnet or a testnet, then this will have to be the address of that testnet or mainnet. Okay, the next thing we need basically is the Starknet account and the Starknet key store. Okay, so we need the account, and here we'll put a path to it, and then the Starknet key store. Okay, here we'll also put a path to it. Okay, so in this case we are going to actually we are going to be creating the this thing. Basically we are going to be creating the account from Katana. That's what we're going to be using to create the account. So we're also going to be using okay. So we'll need Starkly basically. So, okay, let's export. We also need, let's put export here because we'll be needing to export this thing, this environment variable. We're going to be needing to export these environment variables. So for the case of this exercise, basically let's just create a new folder here which we are going to call wallets. Please, in a deployment scenario, this wallet should be in your .env. Okay, it should be in your gtig now. Okay, this wallet should be in your gtignore file so that you don't eventually end up pushing your wallet to GitHub. Okay, normally this wallet is expected to be in your home directory, basically at your /starkly then wallets. Okay, that is normally where it's expected to be, but I'm just putting it here to enable us to I'm just putting it here just to enable us to get or to see what is actually going on, and so that it can enable us to understand what is actually going on. So that's basically why I'm putting it in. Okay, so with this we can then use Starkly to generate a key pair. So we say Starkly signer, and then okay, let's just go to the documentation, and because Starkly has everything in the documentation, so okay, so let's just copy this. Okay, now we're just going to paste it here, and new parts. So what we are going to use here is just our wallets. Good. Okay, so just our wallet, and we're going to press enter. The key stuff file already exists. Does it? Key stuff file already exists, which it doesn't. So let's just figure this out. Okay, so the Starknet book has a good this thing breakdown that we can use, and like it actually makes things clear, it explains things better. So let me just okay. So basically, like when you want to create a signer, because you need a signer for any transaction you want to make on the blockchain, you need a signer. So this is basically the best place to put your wallet, since it's going to be independent of every project. Okay, so you make your directory in you run this command to create this folder, and then when you create your key store and your account, you basically save them in that folder so that you can access it for all your deployments, instead of always like um, creating the folder in your project. Because if you're always creating this folder in your project, you can maybe probably by mistake deploy your private keys, which you don't actually want. But I'm actually doing this inside the project so that um, when I make it available like on GitHub, so for people that will need the repo to at least help them in their development process, it can be easy for them to get the templates, and like can be easy for them to quickly move to testing and deployment on their local environment. So with that, we can use this Starkly signer key store method, or this command basically, to create a key store. Okay, okay. So but then so I basically just saying Starkly signer key store from key, and then we want it to be stored in in wallet in wallet key store dot json. Okay, so when we press enter, we're told to enter our private key. So if you want to do this for deployment, you basically need to provide your private key here to the wallet that you need, like the wallet that you have ether on, that you can use to pay for the deployment. But in this case, since we are deploying to a local testnet, let's just pick one of these accounts here. Let's pick the first account, the private key. Okay, we're just going to copy it and then paste it here. Normally when you paste, you're not going to see anything, but then okay, so next we are told to enter our password. For the case of this example, I'll be using a password of 1234 for the people that want to actually use this wallet I'm creating here in their own local environment. So you can also use it like 1234. So once we press enter, we can see, if we check our wallets, we can see that the key store has been created. Okay, you can see that the key store has been created. So this is what the key store looks like. And okay, let me just remove this wallet from the GTIP now, because I'm going to be deploying it with it too, so that people can have so that people can be able, I'm going to be pushing it to GitHub with the wallet here so that people can have access to it. So next thing, we want to add, so for the key store, in the key store we want to add now be wallet key store should be key store .json. Okay, so that is just this wallet here and the key store .json. Okay, so with this, the next thing we want to do is like to create the account, okay, from that key store basically. So we need to, from this thing we can see, like to create an account we now need to fetch Starkly account fetch and the wallet address, and then we need to put the output file basically. Okay, so I'm just going to copy it and we're just going to paste it here. So with this, our RPC endpoint basically is this is our local endpoint here. Okay, so so that is basically our RPC endpoint. Yeah, and then what we want our wallet to be, the output should actually be in wallets slash accounts, which is wallets like slash accounts .json, and the address is going to be this account address, the account address here. So we're just going to copy it, but in the case of a real deployment, like this is expected to be the address associated with the private key that you used. So with this we press enter and we can see that the account .json has been created for us, and with that we can use it basically to deploy. Since we have the account and the key store, we can use it to deploy our contract. So in the env we're just going to update it. Okay, wallets account, we're just going to so with this we have our key store and we have our account and we have our RPC URL. So basically if we check here, we are going to see those calls we made basically. So any call we make to this local to this endpoint, we are going to be seeing them here. So with this, let's source this env file. So we're going to source .env. Okay, and after sourcing it, let's just confirm that everything is there, like everything have been sourced. So Starknet RPC, good. So we can see it's here that it has been sourced. And if we also check the key store, we can see it has been sourced too. And if we also check the accounts, we can see everything. So everything we need is available to us. So the next thing that we can do is to go ahead with the deployment. Okay, and from here we can see declaring a smart contract, because to deploy a smart contract we first need to declare it. Okay, so we've written our contract, we've compiled it, we've set up the necessary things we need, like the key store and the account, and we've made them available as environment variables. So the next thing is to declare our contract, and what you can do here is to use the statically declare, and then since we've already put our network, our RPC, we've put our RPC endpoint. So basically, what we just need is the statically declare and then the name of the file that we need. Okay, so with that we go statically declare. Oh, sorry. Statically declare, and we statically declare. Then we need to pass in it's a target the contract class. Yeah, contract class.json. Okay, so we have the target dev Cairo Bootcamp, Borderless, then the contract class.json. So this is basically what we want to declare, and when we press enter we need to enter our key store password, which, like I told you, is 1234. Okay, and with this we have declared our contracts on the blockchain, on the local blockchain. If we check statically, we're going to see, if we check Katana, we're going to see that the contract has been declared. We add the declare transaction, you can see it here, and then we can see that a class hash has been given to us. Okay, so after that, since we've declared our contract, the next thing is to deploy that contract. So let's, from the Stackly book, basically we are going to see how to deploy a smart contract. Basically, the Stacknet book is very straightforward, and the links have been sent to each and every one of us, like in the mail. So to deploy a smart contract, basically these are what we need. So just statically deploy the class hash and the constructor inputs, and then the network, basically. So let's then go ahead to deploy. Let's go ahead to deploy our contract. So statically, now this is the class hash, basically. Okay, and we want to use this address as the owner, so let's just copy it. So that is the address we want to use as the owner. Okay, so this is it. So when we press enter, we need to pass in our key store password, and boom, our contract has been deployed. If we check here, we can see it. Our contract has been deployed. This is second mined with just one transaction, basically. So with that, our contract has been deployed. So you can still work with this basically if you want to deploy to a mainnet. If you want to deploy to mainnet or testnet, all you just have to do is to change this to the RPC of the network you want to deploy to, and then the wallet and the key store basically has to be the one that is funded with mainnet or testnet ether that can enable you to make transactions on the network. So with that, we can see basically that we can see that the this thing has been deployed. We've been able to write the smart contract, we've been able to test it, we've been able to deploy it. So let's just go ahead to actually call the contract to see if we actually get the owner, right? Let's just see if we get the owner. So this is the contract address. So what you can do is to use this stackly call, and want to call this the contracts, okay, and want to call the get owner function, okay. And when we call it, we can see basically this is the get owner function, and this is the owner. And if we check, this is actually the owner, 60973. So this is actually the owner that we set when we were deploying our contract. So with this, I really hope we have been able to get a total overview of the whole process, from writing a smart contract to testing it to setting up the environment variables to deployment. And I look forward to us writing, testing, and building amazing products for on StackNet. So if you have any challenge, basically, please ensure to reach out to us on the StackNet Africa Telegram group, or the Borderless group, or just reach out to any of the tutors, and we'll be very much available to help you to get up to speed and push out your project. Also, StackNet, there are some other boot camps, base camps coming up, and everything will be all the information will be passed on Twitter basically. So do well to follow the StackNet Twitter handle, and also be participating in the Telegram activities and the Discord activities, so that you can be kept up to speed with the developments in this space. So with that, we've come to the end of this session basically, and I look forward to us building amazing products on StackNet. Thank you, and see you next time. So we're still awaiting your homeworks, and when you're done with the homework, basically just send a reply to the mail with the link to the GitHub and also your wallet address. So do have a wonderful day, and thank you. Bye.